So what we need to do is we need to create a state table for non-TCP protocols. Almost all firewalls will have this capacity to keep track of things like the state of ICMP. So if we send something like an echo request, what I do is I keep track of the source IP, the destination IP, and the type of ICMP message this is, which in this case is an echo request. I can then send that out to the internet, get the reply back, and just like my TCP state table now, I can verify that this ICMP echo reply is legit. I can change my state and forward the message on. Same thing is true for UDP, although UDP is a little bit special. If you take a TFTP request, for example, Trivial File Transfer Protocol, that uses UDP as its transport layer protocol. When we send that request out and we have a UDP state table set up, specifically one for TFTP, which is required to get TFTP to work, what will happen now is I'll record my source IP and port, my destination IP and port number, and the state, which in this case is my TFTP request. When my outside web server replies then with the TFTP reply, we can then check off and say, yeah, this traffic we're expecting. We can change our state to the TFTP reply and forward our message on. If your application layer protocol you're using is using UDP at the transport layer, oftentimes they make very unusual decisions about how to deal with port numbers, and most UDP-based protocols will change the port number unpredictably. So you actually won't know and you can't predict what the port numbers are going to be. So we need other mechanisms to record in our UDP state tables for UDP-based protocols to allow the communication to come in and out securely.